So for this third example, it's actually 4 different types of problems, but they're all asking kind of the same thing. So we're going to use the given information to name 2 triangles that are congruent, and we're going to explain our reasoning. So from what we know that SAS is the theorem we're going to deal with. So the 2 triangles that I'm going to name, well, first of all, we got to know something about circles. For a circle, this segment right here is a radius. This segment is a radius. So the radius of a circle is the same all the way around the circle. So if we think of these as 2 triangles, these each represent one side, and then that double marking I just made represents a shared side between those 2 triangles. So the way I would name these, I would name it like this. I would say that triangle I'll say RST is congruent to triangle RUT. And part of the reason why we're given that SRT and URT are the same, the angles that are marked congruent, SR is congruent to UR because each one radius is congruent to another radius, right? And then I could say, it's kind of weird to say, but RT, or TR, however you want to say it, is congruent to itself, and that's because it's a shared side. So something about why we can say those sides are congruent, and that's SAS. So it's congruent by SAS. And it's just us being able to tell some things from that diagram, all right? In part B, ABC is a square, and squares have 4 congruent sides and 4 congruent angles. So we can see the 2 triangles that are formed. We can assume angle A and angle C are congruent. Angle A is congruent to angle C because they're both 90 degrees. And a square with 4 congruent sides and 4 congruent angles, well, that means all 4 of these sides are congruent to each other, right? So I could say that, AB is congruent to CD. I could say that CB is congruent to AD. So I could say, and however you want to name it is up to you, but you got to name it in the right direction. I would say that triangle ABD is congruent to triangle, you could do it CDB, or I'd say CBD. Because A matches up with C, B matches up with B, D matches up with D. And that follows our naming from before. So those are congruent by SAS. So it's just knowing what we can mark as congruent and what we can't mark as congruent. And then kind of knowing what we can assume and what we can't assume from our diagrams, okay? For part C, RSTUV is a regular pentagon. So that means it has, fix that, it has 5 congruent sides, okay? And the other thing that we can say is that it has 5 congruent angles, right? So that means that this angle and this angle are congruent. Sorry, I missed a side, okay? So the triangles I would pick out, we should be able to kind of see, but I would say that triangle RVU, this triangle down here, RVU, is congruent to, I could just say, triangle TSU. And the reason I can say that is regular, remembering that meaning, all sides and angles are congruent. So it's some sort of explanation knowing the definition of regular. All sides and angles are congruent. So that's me just knowing the definition of regular and picking out two triangles I can assume are congruent. Okay? And then the last one. Last one's a little tricky. MK is perpendicular to MN. So I'm going to mark that right away. MK and MN. That means that this is a right angle. KL and NL are perpendicular. That is a right angle. And then what I can say now is that LK is 10, MN is 10 because those are each a radius. So it's kind of hard to see. So I'm going to try and highlight it with different colors. But this triangle on the left, this triangle on the right are the triangles I'm trying to show are congruent. So I could say triangle MKN is congruent to triangle LKN. And the reason I can say that, M is congruent to L, because those are right angles. And then I could say, KM is congruent to KL, and MN is congruent to LN, and that is both because plural of radius is radii. Radii are congruent. So that's why I can assume those things. So it's just knowing some features of different shapes to prove things are congruent. So I'm not going to have any further practice off of this, but you can expect a problem like this on the checkpoint. So you're going to move on to the checkpoint after this, and then depending on your score, make sure that you're checking in with me if you're not doing so hot on the checkpoints, and I'll give you some reteaching and I'll help you kind of move on.